All right, folks. Welcome to CST8250, your level 2 database course. Um, I'm going to talk about myself first, and then about the course, um, and then some rules of engagement and that kind of stuff. And then we'll dive into this week's lecture. Okay, so about me. I usually like letting the students know a bit about me before see. All I do is hit the record button. And there's another two there. See? All right. Um, so usually it's good for the students to know where their profs come from. I graduated from college. I don't have a fancy university degree. Uh, Graduated in '96. Um, I've been working as a developer since, pretty much. I work full time and I teach part time. So that has goods and bads for everybody involved. Um, I tend to be more current than the full time faculty that haven't touched a real job in 30 years. That also means I work 50 something hours a week. Um, I'm usually pretty responsive with emails, just so you know. That also means I don't have office hours in the sense of traditional office hours. But the good news is that I have an hour gap from my class before this and this class. So this room could be office hours if needed. As long as you don't mind me probably be eating while we're doing office hours. Um, I'm currently working at IRCC as a technical lead. It's basically a team lead that doesn't have to do any of the HR crap. Um, I'm playing a herd on a bunch of contractors. Before that, because I just joined them in November. Before that, I was at Health Canada for 2 years as a team lead of three teams at the same time. So two development teams and a operational team. Before that, I spent 26 years in the private industry. Of those 26 years, I spent 23 of them, yeah, ish, at the same place. Um, I was a full stack web developer, AWS admin, network admin. I've done it all. If it has something to do with computers, I've done it. The so what kind of person am I? I tend to have at least loose and easygoing teaching style. Um, I don't have lecture notes because I've literally did this stuff for a living for so long that the slides are there to remind me what I need to talk about. Um, I tend to do understand that life happens, like shit happens to everybody. Um, so I'm fairly, you know, understanding when things go wrong. But I also use the line of "I don't suffer fools." If your dog has peed on your laptop 3 times in a row, I think you either need to stop leaving your laptop on the ground or get a new dog, or train your dog better. Um, just saying, within reason. Um, I am not particularly politically correct, and by that I mean I tend to use foul language. I worked in private industry for so long that I can't get over that habit. Um, that kind of thing. Okay, so best practices for attendance in this class. Attend the lectures and the labs, and I'm going to have an aside about that at the end of the intro part. Course moves fairly quickly. Missing one lecture can lead to being lost in the course. Kind of true. This is kind of boilerplate text that a lot of profs use. By that, it means that literally every lecture covers one topic for the following lab. You miss the lecture, you're going to miss the context for the lab. It is what it is. If you're going to have exceptional circumstances where you cannot come to class for a good reason and you're going to miss more than 1 week, let me know. That falls under the category of life happens. Um, Keep up with the reading material. Everything's on Brightspace. I keep meaning to update this slide. Free PDF version of this textbook there's no free PDF because there's no textbook. But there is a bunch of PDFs for you guys to read, and they're free. So I'll provide that. Check Brightspace regularly. I literally have an announcement every week that tells you what is due, what you should be working on, and any other relevant information, especially when I screw things up. I'll put corrections in the announcements. Mind you, I've taught this course so many times that it's pretty rare now that I screw up, but it happens. Complete the labs. Okay, that goes without saying. Do the labs. Like a good chunk of your grade comes from the labs. Labs that are late get a 20% hit right off the top. So, I mean, realistically, I mean, if you're like an hour late, I don't care. But if you're like 2 days late, I'm going to care. The labs are due at the end of the day, 11:59, and oh, if you submitted at 1:30 because you fell asleep instead of hitting the save button. I mean, I'm pretty okay with that. However, anything that is more than a week late, goose egg. The world's easiest grade. I don't even need to look at your submission. In other words, if you are 7 days late, you get an automatic 0. I won't even look at your work. Unless you've contacted me saying, this is the first time my dog peed on my laptop. You know, it's being repaired. I'm getting a new one. It's going to take a week. Um, Ask questions, working groups when you can. Practice as much as needed. This is not like CST8250, which I have taught also, where that course is literally the first half of the semester is like fire hose aimed at your face while you're trying to drink water. This one's not at that pace at all. Actually, this course is kind of content light. So how are we going to cover some of this stuff? The week one, we're going to talk about modeling and basic database design concepts. Week two, we're going to do normalization. I guarantee that week two normalization is the hardest topic of the semester. Um, it used to be further into the semester, and then I realized that it made more sense to have it earlier before the diagramming. Since you guys have already done SQL and you know what database tables look like, then you've done joins. You have some of the concepts of relationships. So I don't need to go. It's better to do the normalization early. Then we're going to do diagrams, um, and then physical diagrams, indexes and views. Week 6 is a really light day. It's a midterm review day. Usually I will do another little bit about normalization, like I'll do in a in-class demo from top to bottom that covers literally all the topics all as one long demo. Takes about 45 minutes to an hour. Then we have the midterm in class. Then we get our week off. That person's okay. Um, then we're going to switch away from design work and we're going to go into administrative work. So this course is kind of strange, where the first half is very theory, the second half is very hands-on. Backup and restores, that'll be strategies and how you do it. Database security, general concepts of security. Um, this is the fun topics for me, triggers and store procedures. Um, Often I actually do 11 and 12 the same week because the lectures are fairly short, so I'll do them at once. Then we talk about transactions. Then we have the final review, but if I do these two the reason I do these two at the same time is the same language. It's not SQL, it's something else. And it's the same language, so it makes more sense to just push through while the topic is fresh. So sometimes we end up with an empty week at the end, which is kind of nice for you guys while you're suffering through your other courses trying to catch up there. Okay, so there is 9 labs, not 10. Forgot to update the slide. The last lab is worth more than the others. This was supposed to say 9. Um, and that slide's wrong too because it's 20%. I inherited the slides from whoever taught this course last semester and they played with them and I didn't realize they changed a couple of my slides. So there's 9 labs worth 40%. It used to be 10 labs and then I realized it made no sense because lab 9 and 10 is the same topic, just two sides of the same thing. So lab 9 is just a fat version of, it's like 9 and 10 put together, but actually a little bit less because it's just one big lab. You're going to have a midterm test, 25%. There's hybrids. Do them, 10%. Not doing your hybrids is a really sucky way to miss your A+. Yes, I've seen that. Where somebody says, oh, I forgot about the hybrids. Can I do them? No. Yeah, maybe if you missed one, I would have let you, but you missed all, you know, like 8 of them. Then is the final exam. You know what that is. Okay, so this is a 324 class. I don't know how many if you've ever seen this kind of notation put before, but 2 hours in class, an hour online, so that's your 2 hours plus the hour of hybrid, 2 hours of lab, 4 hours of study time. The 4 hours of study time is what the people that designed this course figured you'd need. If you're a quick study, maybe you'll study for an hour. If you're a slow study or you struggle, maybe it'll be 5 hours. This last one's kind of fuzzy, depends on you. This is, standard. Um, all right, so sometimes I actually also I include a little bit of extra information about the college here for you guys. I used to do this for level 1, then I discovered there's actually level 2 students that didn't know this stuff either. Um, if you have any kind of challenges with learning, CAL is your resource, Center for Accessible Learning. Um, it just doesn't mean that you are challenged. It could also mean that you have ADHD and you need special support to write tests and stuff. They can actually get you assessed if needed. Peer tutoring, $8 an hour, and they actually do have financial assistance. So if you can't afford $8 an hour, they'll find a way to help you pay for that $8 an hour. I know they used to give you like the first 2 hours for free, and I don't know if they still do that, but they used to be. Algonquin has really good mental health services. So if you're having a really crappy week and you need to talk to someone, there's people here to talk to. And there's a bunch of other support options on these links. When you talk about food, you guys have been here long enough that you know where the food is in this place. By the way, the best food is in CA building across the road. Oh, yes, and we have the awesome 720p projector in this room. My laptop was having kittens earlier because he couldn't figure out what the heck was going on. Oh yeah, you guys know what Brightspace looks like. I hope. Um, okay, so under content, my course shell is super easy. Mind you, your guys' look a little different than mine because I've got the extra crap for the teacher. Make sure you read the course information. I mean, obviously, you know what room you're in for the whole time. Lectures are under lectures. Um, Literally, it's just all the PowerPoints. Um, Labs are here. They're literally in here. They're not Word documents to download. None of that stuff. Um, it's all fairly straightforward stuff. The other good news, I mean, Lab 2 is not due till February. It's pretty generous in the due dates. So again, I give you guys 2 weeks to do the work, and I give you a week grace period if you're willing to take a 20% hit to your grade. So, the only time I start getting really picky about it is before the midterm break, because my grades are due on the Tuesday, or at least my assessments due on the Tuesday, which if you, I can't let you go past that last Sunday. The hybrids are there. Actually, there should be visible. No, the hybrid's not visible. Hang on. Oh, I haven't changed the dates. Okay, I'll be fixing that as soon as I'm done my lectures. They do. Yep, they do. There's a hybrid a week, and the hybrids are locked with the topic of the week. It provides a separate document that covers the material in a slightly different way. So the way I do it in class might be slightly different than how it's written in the document, and that might give you an option to actually maybe understand the material a little better. One per week for the first half, with a summary test type hybrid at the end. Hybrid 6 is like a big fat quiz that asks a bunch of questions from previous hybrids. And then after the break, there's 3 or 4. I don't remember off the top of my head. So 10 hybrids, essentially. Um, and the content is there. I'm going to go fix those dates as soon as I finish presenting the content for today. And then I'll publish them so you guys can see them. Make sure the labs are all, okay, that one's visible. That one's visible. Yeah, we're good. All right, so Brightspace. There's no assignments in this class, no group assignments. Again, something you guys are very lucky about. Students in CP and CET suffer through group assignments, many of them. I hate grading them. I hate dealing with the politics of them. So I'm glad we don't have to deal with this. Okay, now to continue into the actual content of the day. Close this one, bring this one, and slideshow from the beginning. Make sure this is still happening. Yes. Okay. Now that I did the course intro out of the way, we are going to go through uh, the material for today, which will set you guys up for lab 2, which is not even being issued till next week. So lots of buffer. All right. So today we're just going to talk about database design fundamentals. Um, my clicker stopped working. There we go. So I'm going to talk about data and information, um, introduction to the design process, and fundamental database objects. This is actually probably one of the longer lectures of the semester. Why? Because I had to do the introduction in front of it. So you know. Okay, so what is data? It's a thing. Specifically, it's a thing that somebody wants to keep track of. The thing can be almost anything that is describable. So if you can describe it, it's a thing that can probably be stored in a database information-wise. So examples of things: a person, event, or an object. So student is a thing. You're all things. Teachers are things. We're things too. This classroom is a thing. A class, technically, we could call that an event. It's something that's happening. An object, your laptops. These are all things that you can track data about. There's so many things that you can track data on. It's insane. Like if you can think about it, probably somebody's tracking that data somewhere. And even if you can't think of it, I'm sure they're tracking something else. Because I guarantee that the amount of data mining that happens in the world nowadays is a little insane. Google and Facebook know more about you than you do. Why? Because they data mine. All right. So you'll often hear in database the words data and information thrown around. And essentially, they're two parts of the same thing. So, and in the beginning, you have something called unorganized information. It's basically data in a raw state. This is all information that's just being collected. It's not being designed. It's not being prepped. It's just there. Then somebody takes this data, structure, and shoves that structure into a database. Then they take the data and feed it into the structure. And then we have something called organized information. These would be reports. For example, you log into your cell phone provider's account website with your account, and you can see all your invoices. If you look at your bills, you can see all the calls you've made or how many text messages you've sent or received. At least I know with Videotron, my invoices are like 22 pages long. If I actually open the invoice and not just pay the magic number it tells me to pay. So organized information is information that now has value. I mean, unorganized information has value because it's something that you can mine, but once it's been structured and set up, it has immense amount of value to whatever organization is collecting that data. Whether you are an international student that applied through IRCC to get your student visa and your permits to come in, or you work for the Public Health Agency of Canada where you're tracking adverse reactions to vaccines. This is all information that's really, really important. Loblaws, how many bananas were sold last week? They care because Galen needs a new yacht. Depending on who the source of the information is and what they want out of it, the structure will look different. But in the end, it's organized information, and that has value. And the point of learning database design is to take chaos and make it into order. Okay, so what is data? Raw facts, figures, and observations. For example, temperature readings, 22, 23, 21, 24. Obviously, we're talking Celsius degrees. Um, what is information? Data has been processed and organized and interpreted. For example, the average daily temperature, 22.5. So you have the raw data, you process it, putting it into a structure, you do some math on it, and then you have information that comes out the other side. That is literally the purpose of database. Yes, you can do this with not databases, but it gets a little tedious and difficult to work with. So the key takeaway from this first part was data is the input. Information is the output after applying context, meaning, or structure. So you apply whatever transformations you want to the data, and that is suddenly now information. And databases exist to transform raw data into something useful. So how does data get organized? Now that I've talked about chaos and we want to make order out of chaos, there's a few steps. Step one, proper planning. Um, you need to be organized. You have to be prepared. You have to plan your data, as in, hey, I want to do a report on this information. Well, you need to plan where are you going to get this data, the raw data from? How often is it going to get collected? You know, that kind of stuff. What is it? What format is it in? Um, then after that, after you've got your raw data, you do some database design work. These two may happen at the same time, like interchangeably with each other, even partway through. You do some database design, and this is what we're going to be learning for the first half of the semester, for the most part. We're going to learn about conceptual diagrams. Those are high-level diagrams that are super simple. These are used to make sure you actually understand the data. You can use these conceptual diagrams to talk to your managers and their superiors, and or average layperson that you know don't want to hear the technical mumbo jumbo. Logical diagrams and physical diagrams are basically the same thing, except logical diagrams, um, they're not specific to a database platform. The physical diagram is. So this one is we can think about this about blueprints for a house, these three. The first one would be the concept. You know, when you get a house, actually, most people nowadays don't know, but when you go to get a house built, you often, you know, give some money to a design firm and they'll give you some rough sketch of what they think your house is going to look like. That's the concepts. They'll give you the concept. This is roughly the layout. Then they're going to do a set of blueprints, which would be the logical diagram. Then they're going to do the regional blueprints, because depending on where you're building, the rules are different. Therefore, in Canada, it's pretty much the same everywhere. But for example, if you get the house built in New York, the distance between plugs on a wall will be different than they are in Canada. The style of insulation in the wall will be different. The plans are different. A diagram for MySQL will be different than a diagram for Postgres, Oracle, or Microsoft SQL Server. They have different data types, slightly different objects. Therefore, the physical one is the final destination version. And then there's normalization. That is just making sure your data is sane. Your data structure is sane. Not insane, is sane. Um, that's next week's topic, and it's a doozy. But essentially, this just makes sure that you don't cause corruption with your data. Okay, so the database design process is circular. I don't know if they taught you guys about the software development lifecycle, the SDLC. There's a process to developing software, and it's a circle. It has nothing to do with agile or waterfall or any of that crap. Whether it's agile, waterfall, a hybrid, or something else, in the end, it's always the same cycle for software development. Database design has its own thing. It's kind of the same ideas. Step one, you identify the data. Step two, potentially normalize. You do a conceptual diagram, do a physical diagram, you do a review. After that, you may identify things that are missing, and you do it again. At this point, you're probably implementing somewhere here to here. Mind you, I don't have this on the slide because depending on what your job is, you may not even need to implement. You might just be the designer. Literally, there's database architect jobs where that's all they do is create database designs. They don't implement them. They're like the architects. They build a nice blueprint, they give it to someone else, and someone else builds the house. So in here, odds are there's implementation happening here, and then you'll get feedback from the implementation as part of the review stage. You'll discover that you missed some fields, you have some extra data, you missed something. And then you do it all over again, over and over and over again. It's just a cyclical process. It never really ends. Um, at the job I had before I joined the government, where I was for like 23 years, um, I created a database in my, I'd say, the second year there. It's still in use today. Does it look to like, does it, well, how do I know it's still in use? Because the site's still up. Uh, that's how I know it's still there. Um, but that having been said, over those 21 years, that database changed. That we added stuff, we deprecated stuff. I mean, the database has like 300 tables in it now. How many of those 300 tables are actually in use? I think 180, but the other ones, they were just scared to pull them because we don't know what was going to break when we pulled it. So it just grew and grew and grew. It's disgusting. But there was this process the whole time. Every time they needed new features, I had to go look at the database structure and add to it. Okay, so identification is also known as defining the data sources. So I know, really busy slide, eh? One line. Um, so the identification means you're defining data sources. That means, hey, we need to have certain pieces of data. Back in the day, going to age myself here a little bit. One of the really common things that was happening when I first joined the industry was the move away from paper to databases. So you'd actually go into a company, a big manufacturing company, and they don't even have a freaking computer. Everything's done by hand. Purchase orders are paper. Invoices are paper. Somebody would literally fill out invoices and mail them by hand with a typewriter. So then what you would do is you'd sit there and go through these, all this paperwork and identify all the different potential data sources and convert them. More modern is somebody has a big moment of, hey, I want to collect this data. So then you're going to start identifying these data sources. There's just, you figure out where you want your data. So I knew there was more on here. So an existing database is one where you already have a data source. Cool beans. You don't need to go collect it. Clean room implementation. Your boss went away, came back after a weekend and says, I have an idea. That was the worst phrase I always heard. I have an idea. When manager comes back and they have an idea. But at the same time, clean room's the best because you just get to do whatever you want with it. So if your design skills are good, you can actually do a really good design without being limited. Digitizing existing processes. That's the one I was talking about, pulling out the paperwork. Sometimes there's other sources, like you are being given a series of flat files. For example, the Public Health Agency during COVID, they were running a lot of stats. If you remember how cool you could look at all these graphs and, you know, how how bad the wastewater was and all that fun stuff. And the public health agencies were collecting all this data and putting up reports. And all this data would come in from different sources. Some were CSV files, some were coming as Parquet files, some were coming in as other stuff. And then they munged all this data to give you reports. Really cool stuff. As bad as COVID was, it was really interesting from a data scientist perspective. So now that we've identified stuff, now we need to talk about what makes up databases before we get to the physical aspect of it. So when designing a database at the beginning, at the sketching part, we have three fundamental objects. So we only need to learn about three things at first: entities, attributes, and relationships. Entities. Entities are the fundamental object in database design. Last semester, you guys worked with tables. Entities give birth to tables. This is the nebulous concept of a table, which is why this course is kind of interesting to teach. Now that I've taught the level 1 course, I have a better perspective of what you guys have learned coming in. So entities describe the items you're trying to retain information about. So when you're doing the design of a database, at first, you're going to define the entities, and basically they're describing the things you want to collect. An entity class is usually shortened to just entity. Sometimes you'll read and you'll hit somebody's tutorial and they talk about entity class this, entity class that. It's an entity. Somewhere along the way, the object-oriented people decided to try to make databases object-oriented, so they started calling entities entity classes. They're just entities, same difference. So this is the first and last time you'll hear me say entity class. They're just entities, right? An entity eventually becomes a table, usually. Um, an entity instance is a single instance of an entity class, okay? So remember your table? You'd run a query, you had rows that would come back. Those rows are instances, okay? An instance normally becomes a row in a database. All right, so an instance refers to the actual data, not the structure. Every entity instance shares the same attributes as all others. So every row in the database had the same columns, right? So you had a table called students. The student table, in this case the entity, would have an ID, a name, date of birth, and address. All students have that information. There might be extra information that not everybody needs, but all that stuff is there. So the entity is a template. The instance are the filled in records. So the entity defines the structure. The instance is the actual data that goes into it. Using students is a great one because you guys are students. So it's one you guys should roughly understand, right? Algonquin College and Axis, they tracked all kinds of stuff about you. You've got your name, your date of birth, your address, your phone number, your personal email address, potentially your mailing address, your home address, if applicable. If you're an international student, we probably have a student visa number and a passport number. Not sure what they collect about that. I'm pretty sure they have at least your visa number, your student visa. Canadian students would not have that, so that information is not required. But even if you populate a Canadian student with it, those columns are still there. They're just empty because that structure is there for everybody. So when we talk about entities, we have two kinds. A strong entity. So a strong entity is an instance that can live by itself. It exists on its own. For example, a student does not need anything else to define it. It is a thing unto itself. An employee is a thing unto itself. It doesn't need anything else to define it. It is a strong entity. A simple example is a customer record, because a customer record can exist without anything else defining it. It might depend on other entities for things, but is entirely able to exist on its own. For example, you can sign up for an Amazon account and not buy anything right away. Your account exists on its own without anything else because it's a strong entity. It's able to exist by itself. A weak entity. A data instance and a weak entity cannot exist onto it by itself. A good example of a weak entity would be a payment on a loan. Okay? So a loan can exist by itself, basically. Let's pretend that, there's nobody tied to the loan, but the loan exists. However, a payment cannot exist without the loan. For example, you can't walk into the bank and say, take my money. And they go, for what? I want to make a payment. On what? I don't know. Just take my money. You can't. You need a loan, right? So another than you go into the bank and you say, take my money, cries. I guess I'm eating hot dogs the rest of the week. Payment towards your student loan or your car loan or your whatever, your mortgage, whatever is applicable, right? A payment cannot exist without the loan, but the loan can exist without a payment because in theory, you just got the loan, you just got your money, you just bought whatever you used that loan to buy. First payment comes out next month. right? So the loan can exist without the payment, but a payment can't exist without a loan. Therefore, the payment is weak, the loan is strong. Okay, so those are your two fundamental entities. That's the two kinds of entities we see. So often, most entities are fairly strong entities. Um, Another example I like to use is a receipt. You go to the store, go to self-checkout, type in 4011, put it on the scale, put it in your bin, and then you put something else on the scale, 3098, whatever happens to be 3098. That goes into your bag too after you're done. 4011, by the way, is bananas. It's the only one I remember. But the thing is, on the receipt, those items get added to the receipt as you go. Those items cannot exist on the receipt without there being a receipt. In theory, the second you hit start, it starts on your receipt memory. So the receipt exists without your items. I'm simplifying, but it's essentially what it is. Okay, so after we've talked about entities, which are the things, we have attributes. The attributes describe the things. An attribute usually becomes a field or a column. So when you are doing your design, when you're talking about attributes, think back to level one about your columns when you're, selecting columns from a table. Um, During the conceptual design stage, so when you're doing the conceptual design, attributes do not have specific data types. They're just there. They're just a general concept. During the physical design phase, attributes might be split up or combined or dropped outright depending what kind of attributes they are. We're going to talk more about the types of attributes later. Um, but yeah, when you're doing the conceptual design, you just want to make sure you don't want to forget anything. So you literally throw everything at the wall and see what sticks. Um, so just like there's like two major kinds of entities, there's a bunch of different kinds of attributes. Identifiers, those usually become a primary key. So if you remember last semester when you learned about primary keys and, select star where ID is equal, select star from customers where ID is equal to 2, ID is probably the primary key. Those are identifiers. It's what allows you to identify an instance. Atomic attributes. These are attributes that contain a single value. First name, last name, date of birth. Those are atomic. They're not broken down. Composite attributes. These are attributes made up of multiple pieces. A lot of people don't think about composite attributes very much. I'm going to say the one that most people get tripped up on, address. It's an attribute, right? It describes a place. However, when you go to put the address in the database, after it leaves, the conceptual stage, you're probably going to break it up into pieces. Why? So it's easier to query. So you'll probably have address 1, address 2, city, region, state, province, territory, CHOM, whatever you want it to be. Been doing this for a few years. Postal code, country, right? So depending on what part of the world you're in, your address may actually have multiples of these. So address 1 and 2 is common in North America. That'll be your street address and your suite or your postal box number, whatever. City is city unless you're in the UK. Nowadays, there's just one single city field, but in the UK, they used to actually have 2 city fields. Why? Because you'd have some shire near some other shire. No, literally. That was the address where you got this town near another town. And the poor postal people were actually routing it that way. Some countries have dropped postal codes. They brought in postal codes, discovered it didn't work for them, and dropped them. China's a good example of that. They've brought in postal codes and they basically don't use them. Last I was told, not like 2 years ago. So the address is broken down. It's composed of multiple pieces. Therefore, it's a composite. Multi-valued. This is an attribute that's basically a list of values. A good example of that one would be skills. What skills do you have? These will end up being another table. as part of the normalization process. This will be broken down to something else. But it's a list of things, what skills do you have? What languages do you speak? Whatever. Derived. Derived is an attribute that can be calculated from any other attributes. Not necessarily in the same entity, but if every piece of it is inside the database structure and you don't need anything external from it to calculate it, that's derived. The easiest one for everybody to understand, age. You never store, well, during the design stage, it's fine to put age, but you never really store a person's age. You store their date of birth. Because then, now minus date of birth tells you how old they are. To the microsecond, theoretically. Age is the perfect example because you'll store their date of birth. You never need to store their age because it's a calculation. Another one would be order totals. Right, back to our bananas where we bought $10 of bananas and $3 of apples and, a $62 piece of leather steak. Each of those things added up gives you an order total. We don't need to store the order total because we can add it up from each of the line items. Even line items themselves can be, the line total is derived because 79 cents a pound times 1.2 pounds will give you whatever that number would be at the end. Arithmetic in my head has been long gone skill. But essentially that's your line total. So in theory, you never even need to store line totals. You don't need to store order totals. That being said, often there are times where people store the derived values for performance reasons. A small mom and pop shop doesn't need to store it. Amazon, they sure as shit need to store it because their data sets are so large that the performance instead of doing the math every time you look up an order or you do some sums over like was the daily sales, that gets too expensive. So you want to store those derived values for performance reasons. Optional. These are attributes that are not required to define an entity. Perfect example, fax number. Nobody uses faxes in North America except for doctors' offices, pharmacies, and lawyers, and government. But even that, most of the government won't accept fax anymore. Other parts of the world, fax machines are used all the time. Japan, they love their fax machines. It's just a thing there. They just refuse to give up their fax machines. It's only real if it's on paper. And yeah, so for example, your phone number could be mandatory. Your cell phone number could be mandatory or optional because some people don't have a home phone number. They only have a cell. I still have both. Because I pay $6 a month to keep my home phone number. I've had for 30 years, But fax number would be optional. Mailing address might be optional because maybe you live where your mail goes, that kind of stuff. So that's just optional attributes. So talking about the student, the following attributes can be defined. Student number would be your identifier. At Algonquin, your student number is your number, right? 04 something or other after that. Especially if you've got a very common name. Their student number is going to save you. I mean, I had one semester where I had 6 Mohammeds in my class. Slightly spelled differently, but they're all Mohammed. That's when I had really big classes, like I had 142 students that semester. But I had 6 Mohammeds. Just saying, you go up to the desk and say, what's your name, Mohammed? They're not going to find you. The student number, they'll find you right away. Okay? Name. Address. I discussed composite already. Date of birth. Age is derived. So these are examples of, hey, I'm going to define a student class. I'm going to have all these things. And these are just, the types they are. All right. Now to talk about relationships. So relationships is where the name relational database comes from. So in the modern times, God, I feel old when I say that. I feel like back in my day, the children. But modern databases, you have two kinds. You've got relational databases and you've got the the NoSQL unstructured like MongoDB. Those have their place in the world. Their place is not in this class. The relational database is about structure. It's all about structure. Relationships define how various entities are related to each other. There's three kinds of relationships. One-to-one, one-to-many, many-to-many. And there's a few different kinds of notations. Week 3, we're going to learn about one specific notation. But those are often the text-based version. So if we're not using the special symbols, this is how we describe the relationship. One-to-one, literally 1:1. One to n, because one to many, we have n number of instances. Many to many, of course, they can do nn, so they went mn. Many to many, I don't know. All right, so one-to-one relationship. It's a less common type of relationship. It serves a very specific purpose. Essentially, all entities participating in a one-to-one relationship will have only a single relation from one to the other. One of my favorite examples, and this is one most students understand, student and locker, right? You are one student, right? There's only one of you. Each locker, there's only ever one locker of each locker. When you go around and look at lockers, they all have unique numbers, right? So each locker is a single instance. Therefore, a student, when you go and you rent a locker through Access, you can only ever pick one locker, right? You're not allowed to have 2 or 3 lockers. You have one, at least last I checked, one locker. And once you rent that locker can only ever belong to you until you release it. So it's a one-to-one relationship. The student can only ever be associated with the one locker, and the one locker can only ever go to the one student. So it's one-to-one. One-to-many. This is the most common type. It's usually called a parent-child relationship. Also, alternate phrase is master detail. Those are the 3 ways if you look the stuff up online, those are the 3 terminologies you'll find. A given instance, parent, can be related to many other instances, child, in a different entity. For example, we have 2 entities, goose and egg. I used to have a different example, but that one got a little questionable. A goose lays many eggs, but each egg can never come out of one goose, right? Goose can sit and pop eggs out, pop, 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 but that egg only ever comes out of one goose. Therefore, it's a one-to-many relationship. One goose, many eggs. Each egg belongs to one goose. So it's many to one. Many to many. This is also a very common type. Please note, many to many only ever exists during the design phase, the conceptual design phase. Because a many to many relationship is impossible in a physical database. Database servers will not allow you to create them. Why? Because they're dangerous. I got an anecdote on that. So basically put a many relationship, maps out relationships between 2 separate entities where you could have multiple connections going across each other. A good example is student and course, okay? So each of you have 1 or more courses, right? Each course has 1 or more students in it. Therefore, each course has many students. Each student has many courses. In theory, you might not have all the same courses. When you start taking your electives, one person will be in one course, somebody will be in a different course, somebody will be in the really crappy courses because you waited too long to take one of the fun ones like wine tasting. There's a participation fee on that one. It's like $300, but you get to go in once a week and drink wine and give your opinion. Or the study of science fiction. That's another fun one. Or you could be taking music from the 1700s. If that's your thing. I don't know if that used to be one. I don't know if it's still around. But so each student can have many courses. Each course can have many students. Might not even be. They might overlap. They may not overlap. That's many to many. My anecdote is when my third job, yeah, third job. Somebody had managed to convince a database server that we were using at the time, which was a really old product, which didn't have a lot of the modern guardrails to make sure you didn't do something stupid, had convinced it to actually do a many-to-many relationship inside itself, where you had one table related to another table related back to the first table, and there was actually data that was overlapping. And it wasn't there for very long. So I didn't know how stupid this database structure was. And my manager comes up to me and goes, Dan, we noticed there's a lot of cruft. Can you clean this up? I'm like, cool, no problem. Delete from table A where blah. And it ran and ran and ran. Computers were slow in the late 90s, early 2000s. Not that slow. I killed the query, logged in, and tables were pretty much empty. Why? Record A related record B, related record C, related to D, D was related to A. So basically it was a giant circular relationship where basically it just nuked itself. It was lots of fun. I'm glad I had a backup. I had learned that one the hard way to make sure I always had a backup before I did something stupid. Wish I'd remembered it years later, but at least that day I remembered. So many-to-many relationships are physically impossible in modern database systems because they won't let you do it. There's ways around it, and we'll talk about that when we're doing the lecture week 4, how to get around that. Okay, so that's the end of this lecture. I'm going to go back to Brightspace really quick. Brightspace, where are we? Right over here. And, and I'm going to talk about the lab today really quick. The lab today is stupid fast. Now, I don't know whose course shell you used last semester. Did they make you install MariaDB or MySQL? Ah, frig. Okay, uninstall MariaDB. That's why there's some red text here. Yes. Problem is that we're going to get towards labs after the break. You're going to have problems because MariaDB and MySQL don't do permissions quite the same way. Good news: Windows, add, remove, gone. Any Mac users? Okay, 2. Okay, make sure you do this. Brew services stop MariaDB. Brew removed MariaDB. Reboot, and then do the rest. Why? The way Brew installs stuff on a Mac is special. I've actually had it where I did a brew remove, rebooted, and MariaDB was still running. Why? Because we never stopped the service first. I'm not a Mac user, so it took a little while for me to figure this out. I am a Linux user. That's the only reason I was able to figure it out. So do these 2 steps and then reboot, and it's like MariaDB was never on your computer. Then you're going to download, there's instructions for Windows and Mac. Query tool. You can use DataGrip. You can use MySQL Workbench. Take your pick. I don't care. If you're using DataGrip you guys used DataGrip semester 1, right? Okay. You're just going to create a new connection to MySQL instead. That's all. If you're going to use Workbench, cool beans. Oracle finally got around to updating it, so it now works again. For a while, you'd install the newest version of MySQL, and MySQL Workbench would say, I don't know how to talk to it because it's too new. They fixed that. So take your pick. I don't care which one you use. It's irrelevant. Okay, so then there is 2 design tools you're going to set up. So erdplus.com, and I'm going to go to it because I know they just updated the UI on it. I just want to make sure it's not a surprise. Yeah, so you sign up. The world's shortest sign up form. When you log in, it's the new one, right? Oh boy, I'm gonna have to remember my credentials. Anyways, whatever. They just updated it. ERD Plus is really cool. It's actually been created by some university professors, probably by their students. Just gonna say. It is the best conceptual design tool I've ever used. The new one's a little wonky. When it's, I'll be prepped and ready for this when we get to that in week 3. They've changed how the UI works a little bit, and the old version was actually a little easier to understand. The new one is fancy. Um, but it's the only one I've ever used that understands every conceptual object, like every kind of relationship, every kind of entity. It knows what to do with them and actually displays them properly. Don't use draw.io, please. And then the other one is, this used to be called Vertibello. When I went to go log into my account, I noticed it changed names because they got bought out. They're still giving out academic accounts for free. Um, and same thing here. You put in your name, the typical stuff. This one asks for a little bit more. You have to prove you belong to a school now. Yay. Um, and of course, university, because they just think university is the only post-secondary education place. They'll still take Algonquin College. And you set up your password. And this one here is a design tool. And this one here does have the right thing. So this is going to be, hello? Did that take? There it goes. Maybe? There it goes. It's a diagramming tool. Cool beans. Um, I'll show you guys how to use it when it's time to learn how to use it. That's going to be also going to, I'll be showing you guys that week 3. So I'll be showing you how to use both tools week 3 so you can do the labs that go with it. If for some reason this is causing you problems, because it has happened in the past where these guys were they're giving it to you for free. So you know how things are when they're free, right? Sometimes it's a little, if you install MySQL Workbench, you can do all the physical design work in MySQL Workbench also. So your choice, whichever one you want to use. I don't care as long as you give me PNGs, I'll be happy. Okay. And that's not what I wanted to do. I wanted to go back to this guy over here. There. And then you're going to take those 4 screenshots. You go to submit the lab and upload the 4 screenshots somewhere. Oh, this is the teacher view where it's not, it's bringing me to edit it, not submit it. But you guys can go in and submit the work. Then you attach the 4 screenshots as required and done. So it's due January 25th. So for those of you that, like I did say at the beginning of class, I don't take attendance. If you feel like running as soon as we're done lecturing, fantastic. If you want to do it at home, you have 2 weeks. So if you have problems, you can always come back to class the next week and get it fixed. All right, before I hit the stop record button, any questions? Your choice. Do all 4 in a Word document. Okay. Yeah, you can do Word, or you can upload 4 screenshots. Like basically when you add a submission, you can actually add multiple files at once. You can add all 4 screenshots there at the same time and just do that instead. I don't care. As long as if you are going to do a Word document, it's a Word document. Mac users, not pages. That shit's terrible because I can't open those files and neither can Brightspace. So you're just submitting noise. Open Office, LibreOffice, whatever, questionable whether that's going to work or not. So just use Word. I don't care, whichever one you're happy with. You like DataGrip? Fantastic, use DataGrip because you've already used it. Considering most of the work you're going to be doing, you won't be needing DataGrip or Workbench for the actual database stuff until like week 7, week 8. No, sorry, 7. No, 8's the break. 9, 10, 10 or 11 is when you're actually going to need those tools. It's just I want to get it out of the way now to make sure your stuff is in place so that I can't have students come in and say, "Oh, I'm having problems getting my work done. Can you pull up your tool? I don't have it installed." Well, how the heck were you doing the work? Right? This is just me making sure that everything is set up ahead of time. And we can stop thinking about it going forward. Okay? Any other questions? Going once, twice, 3 times. This is the first day. But usually the first day I get a lot of questions. You'd be surprised. And stop.